everyone that's out. You missed example 1. All right, but example 2. So example 2, I think these are more difficult to do. For this one, we only have one transformation. And let's see, Caroline, what's that one transformation that we have here? Vertical expansion by a factor of 3. All right. So, I actually am going to go ahead and make that chart that I made on the last one. So, I'm just doing right now y equals x squared. Okay? So, that means, like I'm going to start with negative 3 squared is 9, negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. Those are just those same points that we graphed on the earlier example, right? So if we have a vertical expansion, we are going to take that graph and we're going to grab it by the y-axis and we're going to stretch it to make it taller and skinnier, right? So if we're making something taller, which coordinate, the x or the y, is going to be affected? The y is right. Because for the y, that tells us how high we go whenever we graph, right? We're not going to change anything about the x because that would be width. We want to change the height of all of these points. So for a vertical, let's put this over to the side. For vertical expansion or compression, multiply the y coordinates by the factor. Okay, so we're going to take all of our y coordinates and we're going to multiply it by whatever factor we are expanding or compressing this by. So here, since we're expanding by a factor of 3, we multiply all of our y coordinates by 3. So that means that instead of 9, I'm going to have 27. That's not going to fit on my graph, but that's okay. Instead of 4, I will have 12. Still won't fit on my graph, but I think I'm going to try to squeeze it on there. Instead of 1, I will have 3. 0 is still going to be 0 because 0 times 3 is 0. 1 will be 3, 4 will be 12, and 9 will be 27. So a lot of times, especially if it's an expansion, a lot of times some of those graphs go off of the graph. That's okay. Generally for a quadratic, I would like to see 5 points if possible. So we're going to have to kind of squeeze this on here. So negative 3, 27, I can't graph. Negative 2, 12, I'm going to put right up here. It goes off of my graph a little bit. I've got negative 1, 3. I've got 0, 0. I've got 1, 3, and 2, 12. So my new graph looks like this right here. And we can see that looks taller and skinnier than it was before. Each point is 3 times as high as it was originally. So right here, this point had a y coordinate of 1. It was 1 high. And now it has been moved up here to be 3 tall. So with a vertical expansion, multiply your y coordinates by that point. You might be able to do that just sort of looking. I usually like to actually write them down and multiply. Sometimes I get mixed up if I don't. Okay. Questions? Expansions or compressions, this one we only had an expansion, but they need to be done before you move something up, down, left, or right. It doesn't really matter whether you flip it first or not. You can flip it or do the expansion or compression first. I usually do my expansions or compressions first. Here's our next one. Okay, so for this one, we've got 3 minus the square root of 2x. This one is clearly a square root function. And let's see what has happened to the square root function. Let's see. Sarah, what's one thing that has happened to this function? Reflected over the x-axis. So that comes from that negative that we have right there. Let's see. Gabby, what's something else that happened to this graph? It is up 3. And that's sort of like the trick that I tried to pull on you on the warm-up, right? Because this 3 out here sort of looks like it should be an expansion or a compression. But really, we could move it over there to the end, and it's just moving it up 3. And then, Nathan, what about the last thing, this 2 right here on the inside? What does that do? It is a compression. Is it horizontal or vertical? Horizontal, good. So horizontal, compression, by a factor of not 2. Okay, remember everything, this is like it's on the inside of the parentheses, right, which you got right with the horizontal stuff. So everything on the inside is backwards. So instead of just being 2, like it was on the last problem because that was vertical, it's got to be 1 over 2. Right, so it's 1 over whatever you have there. Okay, so those are all of our transformations. Okay, questions on that part so far? All right, so square root function. Square root is probably one that you're less familiar with as far as what the graph looks like. So let's make ourselves a chart just of y equals the square root of x, because that's what we're starting with. So if I start with 0, what is the square root of 0? 0. Okay, so I have the point 0, 0. Okay, if I have 1, what's the square root of 1? It is 1. So 1, 1. All right, if I have 2, what's the square root of 2? What did you say, Matt? 1.41, and if it's calculator inactive, which is going to be on the quiz because I don't want you to just like be able to type it into y equals and see what it looks like. If it's calculator inactive, we don't know how to do that, right? So 2 doesn't give us a whole number. Okay. Oh, that's all right. You got something for me? Oh, yeah, thank you. Yeah, that's usually me. Okay. So if I take square root of 2, but that doesn't work. What about square root of 3? That's also not going to work if we don't have a calculator, right? I know that it's like, 1 point something, but not close. What's the next number that I do know the square root of? 4. I know the square root of 4, it is 2. And then 5, I don't know. 6, I don't know. What's the next number I know? Square root of 9 is 3. What about negative numbers here? What if I try to take the square root of a negative number? Doesn't work, right? That's an imaginary number. I didn't wear it today, but I do have a banner back here in the back. I've got me a t-shirt that says square root of negative 1 in heart math because I is the square root of negative 1, right? So we can't take square roots of negatives, or not, at least not get a real number that we can graph. So this graph is not going to have any negative points on it. So we're going to have 4, 2 is a point on a graph, and 3, 9. Notice it's kind of backwards from the quadratic. It's because a square and a square root undo each other, so these are inverses here, which we'll talk more about later. All right, we can reflect or do the horizontal compression first. I think the compressions are the most difficult. I usually try to do those things first. Okay. Plus, they have to be done before you move anything up, down, left, or right. So for our vertical compression or expansion, we multiplied the y-coordinate. What do you think we're going to do for the horizontal expansion or compression? Not divide the y-coordinate, but we're going to multiply the x-coordinate here. So for horizontal expansions or compressions, multiply the x-coordinate. By the factor. And that's where it's really important to get your factor right, because this is a horizontal compression. This is supposed to squish this graph in this way. So I've got to make sure I've got 1/2, because if I just put 2, it's not going to squish the graph. It's going to stretch it out that way. So make sure you've got that 1 over that number to get that factor. So if I do that, 0 times 1/2 is still just 0. 1 times 1/2 is going to give me 1/2. Well, let's not do 2 because we don't really even have that point. 4 times 1/2 is 2. 9 times 1/2 is 4.5. So if I graph those new points, 0, 0 stays right where it's at. You're going to find that happens a lot with 0, 0. 1/2 1 is going to be about right here. See how it's like half the distance that it originally was from that y-axis? Then we've got the point 2, 2, and the point 4.53. So 4.53 is going to be about right here. So some of these you might still have to estimate because it's going to fall between grid lines. Now I could do this. What's the next number I know the square root of? Besides after 9? Not 12. 16. So the square root of 16 is 4. That doesn't fit on my original graph, but you don't have to do this. But if I take half of 16, that's 8, right? So the point 8, 4 would also be on the graph. That point's optional. You don't have to add it in. But if you just want to be fancy, you can. So we our blue points here took care of that horizontal compression. So that is done. Now we need to reflect those over the x-axis because we have to do that before we move anything up, down, left, or right. So now we're only looking at the blue points, and we want to flip all of those over the x-axis. I'm going to do this in red here. So 0, 0 stays where it's at. 1/2 1 becomes 1/2 negative 1. 2, 2 is 2, negative 2. 4.53 is 4.5, negative 3. And 4, 8, which is an optional point anyway, is going to be 8, 4 is 8, negative 4. So just flip all of those blue points upside down. So we've taken care of that. Okay. Last step, everything needs to move up 3. So we take all of our red points. I'm going to use green for this. And everything moves up 3 points. So we just take all those points, move them up 3. And then that's our last thing that we've got to deal with. So I'm going to draw the line in this time. Make sure with the square root, we don't want to draw the line continuing this way because it doesn't, right? That 0, 0 was a stopping point, so we don't continue that line on. We'll put an arrow on this end, though. That one's pretty bad. I feel like that's one of the worst ones you'll have to. Okay, questions on 3? Now 4 looks worse. 4 looks a lot worse, but it's not. It's not. Because what type of graph is number 4? It's y equals x. It's linear. There's no squares. There's no square roots. There's no cubes. There's just an x there, right? So this is linear. So I'm going to tell you all now. I'm going to warn you all, and then half of you, maybe not half of you, at least 5 of you are going to forget it. I always offer this. If you have something that's linear, you already know how to do this. You learned a much easier way to do this whenever you were in Math 1. If you have a line, use y equals mx plus b. Do not try to graph this using transformations. It can be done, but the likelihood that anyone in here, myself included, is going to do that transformation correctly after all of those things have happened to the line is pretty low. But if you use y equals mx plus b, it's really not a hard problem, or it shouldn't be if you remember what you're doing for Math 1. All right. So if you see a line, don't try to use transformations. What we're going to do is we'll distribute that 1/3, which multiplying by 1/3 is really like dividing by what? If we multiply by 1/3, it's the same as dividing by 3, right? So 1/3 of 3 is just x, or 1x, and then 1/3 times 12 is going to be -4 plus 7. So we get y equals x plus 3. All right, so we just distribute that 1/3 here. If you're having trouble with that, when you do 1/3 times 3, that's to multiply fractions. We got to put that over 1. We just multiply straight across 3 over 3, which is 1. All right, 1/3 times 12 is 12 divided by 3, which is 4 there. So, so we just distribute, then you just combine that -4 and the +7 to get that +3. So I didn't write the 1, but you could if you need to, right there. Our y-intercept of that is 3. So I have a y-coordinate at 3. The slope is 1, which really I need to be 1 over 1. All right, so I go up 1 over 1, up 1 over 1. And then just draw that line in. So I'm telling you right now that there is a linear one on the quiz. That you have, well, you don't have to graph it by hand because it's multiple choice, but you have to match the graph to a linear. So if everybody in the whole class gets the linear question right, then I will give everybody in the whole class 10 extra points on the quiz. But everybody's got to get it. If one person misses it, you don't get the extra credit points. Because every year, there's always a handful. Usually it's more than one. Usually it's like 4 or 5 or 6 of you that try. Like I can tell you were trying to use transformations. I can see the dots. Now last year I gave this on Canvas, so I couldn't see the dots there. But when I gave paper pencil, I would see the dots. They'd move things up. They'd try to compress, and never did they get it right because it's terribly difficult to get that right if you're doing it that way. So if you see one that looks impossible, ask yourself, is this linear? If all you see is an x, y equals mx plus b. Okay? Everybody here, I feel like, can probably do this. Everybody remember y equals mx plus b from Math 1? So I think everybody can do it. The key is realizing that you've got to do this, right? Because somebody forgets. But if everybody remembers, then everybody gets 10 points on the test. If everybody gets the linear question right, everybody will get 10 points on the quiz, not test, quiz. Okay? I've not had a class get the 10 points yet. I've offered it for several years now, and I've never had a class get the 10 points. But you guys seem pretty smart. I think you guys can be the first one. All right, let's move on. Okay, these are absolute value bars here. They really should probably be a little taller. They don't look like the prettiest ones. Okay, so absolute value graph is what we're starting with here. And let's see, so we've got absolute value. So, let's see. Allie, give me one transformation that has happened here. All right, so flipped over the x-axis. Okay. Let's see. Lyra, give me another one. It is not. Which number are you looking at for that? Okay. So if we're adding or subtracting, that means it's going to be up, down, left, or right. It's when we're multiplying that's a horizontal compression, and you would be right if like it was 2x instead of x plus 2. So that plus 2 is going to move it up, down, left, or right. Which one would that be here? Inside is always horizontal, right? So, yeah, sometimes it's hard to get the rules down. You just need some more practice with it. So anything on the inside is always horizontal. It's either horizontal compression, like you said at first, or it moves it horizontally, left or right. And everything on the inside is always backwards also. So since we've got that plus 2, it'll be left 2. Good. Okay, so that's a couple of them. Let's see, Lakin, what's something else that happens here? It goes up 5. Here, that's the same trick from the warm-up. That 5 really could go over there at the end, right? And then we've got, let's see, the 3 is the only thing we have not dealt with. So, Beth, what does that 3 do to the graph? Okay, is it added, subtracted, or multiplied? It's multiplied. So multiplied tells me it's going to be expansion or compression. Okay, it's vertical. And is it going to be expansion or compression? Expansion by a factor of 3. Good job. Okay. All right, so absolute value graph. If I have the absolute value of a positive number, it is just itself, right? So if I have the absolute value of 1, it is 1. Absolute value of 2 is 2. Absolute value of 3 is 3. Absolute value of 4 is 4. You can keep on going. I'm going to just stop there, right? If I have absolute value of a negative number, it is the positive of that number. So like absolute value of negative 1 is positive 1. Absolute value of negative 2 is positive 2. Absolute value of negative 3 is positive 3. Absolute value of negative 4 is positive 4. I'm going to stop there, but these keep on going in each direction. So that's what we're starting with here. Always, you can kind of think of like it's just a line with a slope of 1, and on the left side it has a slope of negative 1 there. So this is what we start with for absolute value. Now, just because absolute value makes things positive doesn't mean everything has to be positive here, because when we flip things and move them, it can flip it so that it is actually negative. So we've got to do a vertical expansion and a reflection over the x-axis. Let's do the vertical expansion first. Okay. So vertical expansion takes all of my y-coordinates and multiplies it by the factor. Right? So let's just make ourselves a table here. I'm going to do the right hand side, and then the left hand side is just going to be the reflection of that. So 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. I'm going to do these points, and then I can just reflect it for the negative side because it's going to be symmetric. So if I have a vertical expansion, I need to multiply my y coordinates because y affects verticalness by 3. So this will be 3. This will be 6. This will be 9. This will be 12. It ends up going off of the graph, so we'll leave it alone there. So the point that was 1, 1 is now going to be 1, 3. And the point that was 2, 2 is now 2, 6. And the point that was 3, 3 is now 3, 9. What's the slope of the line on that side? It's a slope of 3. All right, so you can kind of think of that vertical expansion as a slope only for absolute value. It doesn't work for quadratics or cubics or anything like that. And then so I'm just going to flip these points over the y-axis to get that. Any questions? All right, so after you do your expansions or compressions, you got to do any reflections that you may have. So we've got to flip this over the x-axis. So that is going to look like this. Just flip all of those points over the x-axis. And then I usually do my translations at the same time. So left 2, up 5. We're just going to take all of these points and move them left 2, up 5. So the left 2, up 5. That vertex would end up here. And it would look like this. That one's a pretty tough one too because you have so many transformations. Although kids usually do a little better with absolute value than they do with like square roots or cubics or those that we're a little less familiar with. Okay, questions? Here comes our next one. Now these are the ones that are weird. These are those strange ones that we looked at the other day, or at the beginning of class today. So what's tricky about this is you have to decide what type of graph you're even starting with, right? And so what type of graph are we starting with here? The quadratic, okay? So quadratic is our parent graph, which means these absolute value bars are not our graph, or not the graph we start with, but they are a transformation that we're going to have. So what you need to do for these is you need to pretend like they are not there at all first. Okay? Your absolute value bars, you want to do those last if they're around the whole function, which they will be if you see them in this fashion. So if they were not there at all, what does that minus 7 do to the graph? Down 7. Right? Because the absolute value bars are not your parentheses here, because they are a transformation. If it is absolute value graph, like you're starting with absolute value on the last one that we did, then they act like your parentheses. But if it is a quadratic that you're starting with, they're not your parentheses. It's a transformation. So we're going to do a quadratic down 7, and then the absolute value bars, which are actually there, we're just pretending like they're not to do the first part, they are going to flip the negative parts. So we will start with just graphing a quadratic that's been moved down 7. So the quadratic, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, and then I'm just going to reflect those over the y-axis. Alright, so that's just our basic quadratic. We need to take all of those points and move them down 7 units. So I'm going to do that in blue. Now, I normally do not draw the lines in until I'm finished with the graph, but this is an exception here because I think it's a little bit difficult to see what's going to happen here unless you have the lines. So this is not my answer yet, but I am going to draw in the line. And I'm also, just for a little bit of clarity, I'm going to erase those original points there. Some of you may not like having those original points anyway, so you might erase them every time. That's fine. I'm going to erase them here because I think they kind of get in the way of figuring out where everything's at. So we've got a quadratic that's been moved down 7. What we need to do is we need to take everything that's negative and flip it over the x-axis. Anything that's negative is all this part right here that's below the x-axis. Anything that has a negative y-coordinate. All right. So that means that this point and this point are going to stay right where they're at. We don't mess with those because they're already above the x-axis. But these 5 points right here that are below the x-axis, they have to be flipped over that x-axis. So I'm going to do this in red. And so this point right here will flip up here. This point right here is going to go here. That vertex will be here, here, and here. Okay, so we flip those points over the y-axis, and this is what we're going to do. We will start, doesn't matter whether you start on the left or right hand side, but I'm going to start over here on the left hand side. I'm just going to trace the graph all the way down till I hit the x-axis. I cannot go below the x-axis because if I do, then I'm negative and the absolute value can't be negative. So I go all the way down till I hit the x-axis. I don't know what point this actually hits. It's somewhere between 2 and 3, but I don't know exactly where it's at. Then, once I hit that x-axis, I've got to bounce back up and go through these points. I'm going to go all the way down to the x-axis again, but I can't go below the x-axis, and then I'll trace the rest of the graph up here. So that red graph is my final graph. So you can just point an arrow to it saying, what's your final, make it a little darker, do something so that you know that's the final graph. Okay, questions? All right, we've got one more to do. Well, no, we've got 2 more. We've got to do 8. 8's the one we do have to do. I'm trying. I want you to have a little bit of time to work. Let's skip 7 for now. It's a quadratic. It does have a horizontal expansion, but horizontal expansions you're just going to multiply your x-coordinates by 2 there. So we've done several quadratics. I think you guys can probably do that one. Let's do 8 because 8 we have not done a rational yet. So if we just graph 1 over x, that's your parent rational function, right? So if I make like a table for that, if I plug in 0, I get 1 over 0. Can I divide by 0? I cannot. So that's undefined, which means I can't graph that. So I'm not going to have anything at 0. I'm going to have what we call a vertical asymptote right there. So let me draw that in. So right there at the y-axis, where x equals 0, everywhere there, I'm not going to have anything. All right. If I plug in the number 1, I get 1 over 1, which is 1. I can graph that point, right? If I plug in 2, I get, for 2, 0.5, right? So 2 is 0.5. If I get 3, that's when I'll get 0.3 repeating, right? So 0.3 repeating. And then 4, 0.25. It's getting almost impossible here to really graph anything that means anything, right? Will that ever become negative as we put bigger numbers in? No. What's going to happen to it? Those decimals are going to get smaller and smaller and smaller and smaller. So what happens is we just get closer and closer and closer and closer and closer and closer to 0. So on this side, you have, no, this is still our parent. You have a horizontal asymptote. You're going to get closer and closer and closer to 0. Mine shouldn't, but it looks like it goes back up, but it shouldn't. Just do the best you can. Don't. And then on the left-hand side, we got to go to this vertical asymptote. So it looks like this. Okay. If I did with negative numbers, the same thing. If I plug in -1, I'd get -1. So that'd be this point right here. And then -2 would be -0.5. So that would be this point here. And -3 would be -0.3 repeating. So that'd be here. So you can see the same thing is going to happen over here. These lines just get closer and closer and closer to those asymptotes. I'm going to draw in, let's use blue. Now this is just the parent. I haven't done anything to it yet. All right. This is another time that I usually draw the lines. Okay. Now the only points I'm going to require you to have are 1, 1, and -1, -1. Those are like our points that I need to see, make sure are graphed perfectly whenever you move these. And so whenever I move this, I've got the x -3 right here, and then I've got the +4 on the end. So Caroline, what's the +4 going to do? Up 4. And then, let's see, Jasmine, what does the -3 do? Right 3. I am not going to give you expansions or compressions on rationals. I might give you a reflection, you just flip it. But I will not give you expansions or compressions because they become way too difficult for us to try to graph by hand. So what's going to happen here is I've got to move this up 4. When I do that, that horizontal asymptote moves up 1, 2, 3, 4. And I've got to move to the right 3, so that vertical asymptote moves to the right. Oops, not that. That back. What's this green line here? Come on, green line. There we go. 1, 2, 3. You don't have to draw in those asymptotes, but you have to make sure it doesn't cross those. I usually draw them in as a dotted line because they are not part of the graph. And so once you get those asymptotes drawn, you've got the point that would be 1, 1, and the point that would be -1, -1. And you're just going to draw your graph so that your graph approaches those asymptotes in each direction and doesn't cross them, although that one looks like it about did. So this is what I'm looking for a rational. I will not give you any expansions or compressions on rationals. You can do them, but we don't have time to worry about things like that. Okay, questions? All right, so your assignment that you're going to have is this worksheet here, and I'm going to give you guys a piece of graph paper here in a second. that you do at least 8 of them. I would suggest that you do them all, but that might take a little while, and I don't want you to have homework for like 45 minutes, an hour, and have to look at that practice test. So only 8 are required. You can do any 8 that you want. You don't necessarily have to do one through 8. And I think I have my graph paper here. So let me give everybody a sheet of graph paper also. Please do this on graph paper. Questions are for homework. You've got about 10 minutes right now, so go ahead and quit recording.